Okay, as promised, here's my solutions to the June 17 paper 1. Okay. So let's make that a little bit bigger. Okay, hopefully you can see that okay. Okay. I will make that bigger as we go through the paper. So, the scatter graph shows maximum temperature and number of hours of sunshine in 14 British towns on one day. Okay, rather than calling this point as an outlier, so the coordinate is 10, 19. So 1, A, 10, 19. Okay, for all other points, write down type of correlation. Okay, so obviously it's a positive correlation. On the same day, in another British town, maximum temperature was 16.4 degrees. Estimate hours of sunshine. So for this, I need to put in my line of best fit. Okay, so my line of best fit, then go along to 16.4. Sorry, go up to 16.4 degrees. So 16.4, 16's there, 17's there, so 0.4 is 2 little notches. Read across, read down, and it's going to be somewhere around 13 hours. Okay, obviously, if I had the paper printed, I would have done my line of best fit properly. A weatherman says the temperatures are higher on days when there's more sunshine. Does the scatter graph support what the weatherman says? D, yes, as hours of sunshine increases, so does the temperature. Okay, question 2. Express 56 of product its prime factors. So remember when it asks for it is as the product, we've not only got to do the factor tree, but we've then got to write 56 equals. Okay, 56, so 2 and 28, 2 and 14, 2 and 7. So 56 equals 2 multiplied by 2 multiplied by 2 multiplied by 7. You could write it as 2 cubed multiplied by 7, but it doesn't ask for it in index form. So on the safe side, leave it as 2 multiplied by 2 multiplied by 2 multiplied by 7. Okay, work out 54.6 multiplied by 4.3. 54.6 multiplied by 4.3. 3 times 6 is 8, carry 1. 12 plus your 1 is 13, carry 1. 15, 16, carry 1. 0 because this is 10 times bigger. 24, carry you 2. 16, 8, carry 1. 20. So 8, 7, 4, 3, 2. 2 decimal places in the question. So 2 in the answer. 234.78. Question number 4. So we did this one for Kira. I think it was for Kira. So that's 3, that's x, that's 3, that's x. So this area is 9, this area is 3x, this area is 3x, this area is x squared. So the area is x squared plus 6x plus 9. Gives you 3x plus your 3x is 6x. And it tells you that is equal to 10. So if I subtract 9 from both sides, it equals the 1, which is what it's asking to show. Okay, so question 5 is a rectangle. So that's 5, that's 12, that's 5, that's 12. So diagonal, using Pythagoras' theorem, this comes out to be 13. Okay, or you should recognize a 5, 12, 13 triangle anyway. Okay, so the weight of the metal is 1.5 kilograms per meter. So if I add them up, 5 plus 5 plus 12 plus 12 plus 13, so that equals 10, 20, 30, 40, 44, 47. 47 multiplied by 1.5, 5 carrying 3, 20, 0, 7, 4, 5, 0, 7, 70.5 kilograms is my answer. Question 6. Show the parallel. So if they're parallel, then they have the same gradient. So y equals mx plus c is the general form of the equation of a straight line, where m is the gradient. So if we can show that the m value is the same for both, then they are parallel. So obviously the first line is y equals 3x minus 2. So the gradient is 3. So the second line says 3y minus 9x plus 5 equals 0. So I want it in the form of y equals. So let's take everything other than the y to the other side. 3y equals 9x minus 5. Divide by 3, y equals 3x minus 5 thirds. So gradient is 3 again, therefore they are parallel. Both have gradient of 3, therefore parallel. Okay, so question number 7. So there's 10 boys and 20 girls. So we have our means, boy, girl, total. So number of boys is 10, number of girls is 20, so total number is 30. The mean mark for all the class is 60. So total score would be 60 times by 30 is 1,800. The mean for the girls is 54. So the total score would be 1,080. Okay, so that means the total score for boys would be 720. So the mean would be 720 divided by 10, which is 72. Okay, so remember you calculate your mean by taking your total divided by how many you've got. So if you've got your mean and your number of bits of data, multiply them to get your total score. Okay. Question number 8. 7.97 times 10 to the minus 6 is 0.0000797. B, 2.52 divided by 4 is 0.63. And 10 to the power of 5 divided by 10 to the minus 3, so 5 minus 3 is 10 to the power of 8. So I get 0.63 times 10 to the power of 8, which is 6.3 times 10 to the power of 7. And that is because 0.63 is 6.3 times 10 to the minus 1. Minus 1 plus 8 is 7. Okay, I hope that makes sense. So, question 9. Jules buys a washing machine, 20% VAT is added to the price of the washing machine. Jules then has to pay a total of £600. What is the price of the washing machine with no VAT? So, if I've added on 20%, I've paid 120% of the actual value. Okay, or the original value before VAT, and that is £600. So if I divide that by 6, I get 20% is £100. So 100% would be £500. Okay, so that's divided by 6 times by 5. Okay, so my answer is £500. Okay, show that x plus 1, x plus 2, x plus 3 can be written in the form of ax cubed plus bx squared plus cx plus d, where a, b, and c and d are positive integers. So whenever you see this type of question, just expand the first two brackets. So that gives me x squared plus 3x plus 2. And then I've got to do x squared plus 3x plus 2 multiplied by x plus 3. Now, there's a couple of ways to do this. You can use your crab claw, but obviously be a little bit of a demented crab claw because it's going to have 3 bits coming from here. Or you can use your box method. So you've got x plus 3, x squared plus 3x plus 2. X times x squared is x cubed. That's 3x squared plus 2x. So that'd be 3x squared plus 9x plus 6. So if I simplify, I get an x cubed, 6x squared, 11x plus 6. Okay, so question 11. Write down the coordinates of the turning point. So the turning point is this point here. So that turning point is 1 minus 3. So part B says write down estimates for the roots of fx equals 0. So that's saying where does it cross the x-axis. So it crosses the x-axis here at 2.75 and minus 0.75. So 2.75 and minus 0.75. Okay, and use the graph to find the estimate for f of 1.5. So when x is 1.5, go down to the curve, and I get minus 2.8. Question number 12. Find the value of 8 to the power of 81, to the power of minus a half. So 12, 81 to minus a half. So 81 to the half to the power of minus 1. Well, the power of a half means the square root. So square root of 81 is 9 to the power of minus 1. So that's a reciprocal. So it's 1/9. B is 64 over 125 to the power of 2/3. Okay, so let's do 64 over 125 to the power of a third, and then square that. So the power of a third means the cube root. So the cube root of 64 is 4, cube root of 125 is 5, and then I've still got to square that answer. So I get 16 over 25. So the table shows a set of values for x and y. Y is inversely proportional to the square of x. Find an equation for y in terms of x. So A, y is inversely proportional to 1 over x squared. So y is equal to some constant over x squared. So let's choose a value. Let's go for when x is 1 and y is 9. So when x is 1, y is 9. So 9 equals equals k over 1 squared. So 9 equals k. So therefore, y equals 9 over x squared. Now I can quickly check that by going to the when x is 3, y is 1. 9 divided by 3 squared is 1. So yes, so that is the right equation. So B says find the positive value of x when y is 16. So B says y is 16, so that's 9 over x squared. So let's take the x squared up to here. 16x squared equals 9. So x squared equals 9 over 16. So x equals the square root of 9 over 16. So that is plus or minus 3 over 4, because remember there's a positive and a negative solution. And it says find the positive value of x when y is 16. So x equals 3/4. Okay, so question 14. White shapes and black shapes are used in the game. Some of the shapes are circles, some of the shapes are squares. The ratio of the number of white shapes to the number of black shapes is 3 to 7. The ratio of the number of white circles to white squares is 4 to 5. The ratio number of black circles to black squares is 2 to 5. Work out what fraction of the shapes are circles. Okay, so the ratio of white shapes to black shapes is 3 to 7. Then it says white circles to white squares is 4 to 5. So there's 9 parts in here. Okay, and then it says black circles to black squares. So there's another 7 parts in there. Okay. So if we multiply this by 9, I'm going to get 27, and multiply this by 9 to 63. Okay, so what fraction of the shapes are circles? So that would mean within the white shapes, the circles to squares, white circles to white squares, I've multiplied by 9. So if I multiply the 4/5 by 3, I'll get 12 to 15. The black circles to black squares, I've multiplied this by 9. So if I multiply the 2 to 5 by 9, I'd get 18 to 45. So the fraction that are circles is 12 and 18. So it's 30 out of 90, which is 1/3. I'm sure there's more than one way to do that, but that's the way that I saw it this time. I'll probably do the question again and see it a different way. Okay, so let's have a look at question number 15. Okay, work out estimate for the volume, estimate for the height of the cone. Okay, so that means that we've got to round everything. Okay, so I'm looking at it, I know the volume of the cone is 1/3 pi r squared h. So pi is roughly 3. The volume of the cone is roughly 100. The radius of the cone is roughly 5. Okay, so part A, 100 is approximately 1/3 times by 3 times by 5 squared times by the height. So 100 is approximately 1/3 times by 3 is 1, times by 25 times by the height. So the height is approximately 4. Okay. Do you use a calculator to work out the height of the cone to 2 decimal places? Will your estimate be more than John's answer or less than John's answer? Okay, so let's think about what we've done. Obviously, we've rounded that down, we've rounded that up, and we've rounded that down. So we've divided by a number that's smaller than what we've got would have had. So 5 squared, 5.13 squared is obviously bigger than 5 squared. 1/3 of pi is bigger than this. So we'll be dividing by 100 by a much bigger number than 25. So our answer will be less. So will your estimate be more or less than John's answer? So our answer will be more than John's answer. John's answer will be less. Okay, as we've rounded these two down and this one only slightly up. Okay, so question 16. N is a positive integer greater than 1. Prove algebraically that n squared minus 2 minus n minus 2 squared is always an even number. So let's do this expansion here. N minus 2 multiplied by n minus 2 gives you n squared minus 2n minus 2n plus 4. That's n squared minus 4n plus 4. So n squared minus 2 minus, in bracket, n squared minus 4n plus 4. So the n squareds will cancel each other out. Okay, minus gives you plus 4n. Minus 2 minus 4 gives you minus 6. So that is 2 lots of 2n minus 3. So if I'm multiplying by 2, therefore even number, as 2 as a factor. Okay. All multiples of 2 are even. Okay, so question 17. There are 9 counters in the bag, 7 of the counters are green, 2 of the counters are blue. Okay, Mia takes at random 2 counters from the bag. Work out the probability that Mia takes 1 counter of each colour. You must show your working. So, probability tree is one way to do it. Okay, so you'd have green, blue, green, blue, green, blue. You put on your probabilities, and then you'd want this root and add them together. The other way to do it is to go, well, the probability that the first counter is green is 7/9. The second counter being green would be 6/8. The probability of green is 42 over 72. Blue would be 2/9 and then 1/8. So that's 2 out of 72. Add them together and I get 44 out of 72. Okay, now this is the important thing. Read the question, children, because I've done both the same and it says one of each colour. So, probability the first one's green is for 7/9. Second one, blue, 2/8. 14 out of 72. First one, blue, 2/9. Second one, green, 7/8. 14 out of 72. Add them together and I get 28 out of 72. That's better. Make sure you read the question before you jump in and answer it. Okay, good lesson to learn there. Okay. My excuse is it's Sunday afternoon. Okay, so let me just minimize that for a second. ABCD is a rhombus. The coordinates of A are 5, 11. The equation of diagonal y dB is y equals half x plus 6. Find the equation of diagonal of AC. Okay, so I'm just going to quickly draw a diagram. So there's my diagram. Okay, so we should know that our other diagonal crosses at right angles. Okay, and then we should know the gradients of the two when they cross at right angles, when they're perpendicular, gives you -1. So we know the gradient here is a half. So half times by gradient of the other line is -1, is -1 divided by half, so that's -2. So the gradient of this line here is -2. So we know it's y equals -2x plus something. It goes through the point 5, 11. So when x is 5, y is 11. So 11 equals minus 2 lots of 5 plus C. So add the 10 over, 21 equals C. So the equation of the diagonal AC is y equals minus 2x plus 21. Okay, so what's the next question? Okay, let me just minimize it so I can see the diagram properly. Okay, got it. So our parallelogram A, B, C, O. So that's A and that's C. Okay, X is the midpoint of the line AC. Okay, OCD is on a straight line such that OC to OD is K to 1. Okay, so D's out here somewhere. Given that X to D is 3C minus half A, find the value of K. So O to C is K, and this is 1, so it's K out of K plus 1 and 1 out of K plus 1. Okay, so find the value of K. So we know that X to D is that. So A to C will be minus A plus C. Okay. So C to A will be A minus C. So X to D, I could travel from X to A plus A to O plus O to C plus C to D. Okay, so we know that X to A is half of C to A. So X to A is half A minus a half C. So that's half A minus a half C. A to O is minus an A. O to C is plus a C. And then I've got this little bit here, which I'm going to call, just leaving as CD for the moment. Okay, so let's just pause that for a second. Okay, so if we look here, this is what X to D is. And we know that X to D is 3C minus a half A. So I've got the minus half A bit. I've got half a C. So this C to D must be the remaining 2.5 C. 2.5 C. Okay, but we know that O to C is K out of K plus 1, the whole length. If this length K, this length 1, the whole length is K plus, it tells us the ratio. Okay? So k over k plus 1 equals 1c, and 1 over k plus 1 equals 2.5c. Okay, so we know that k must be less than 1, okay, because I'm dividing by 2.5. Okay, so 1 divided by 2.5 is 0.4, so k must equal 0.4. Okay, that was a tough one, guys, so just bear with it, and we can go through some more of those when I see you in lessons. So question 20. Solve algebraically simultaneous equations. So I've got x squared plus y squared equals 25 and y minus 3x equals 13. So if I rearrange this to give me y equals 3x plus 13, I can then replace this y here with this here. So now I've got x squared plus 3x plus 13 squared equals 25. So I've just replaced the y with 3x plus 13 here. So now I've got to expand this bracket out. 3x plus 13 multiplied by 3x plus 13, 9x squared, 39x, 39x, 169. So now x squared plus 9x squared plus 78x plus 169 equals 25. So now it's starting to look a little bit like a quadratic equation. 10x squared plus 78x plus 144 equals 0. Okay, so now there's a couple of ways to solve it. We can complete the square, we can factorize it, we can use the quadratic formula. The first thing I notice is that 2 is a factor of all of them. So if I write it as 5x squared plus 39x plus 72 equals 0, that might make it a little bit easier to factorize. So I'm going to try factorizing 5 times 72. 5 times 72 is 360. So I'm looking at two numbers that multiply together to give you 360 and add together to give you 39. So 36 and 10, no. 24 and 15, yes. 240 plus 120, yeah, 24 and 15. So if I replace this, 5x squared plus 15x plus 24x plus 72 equals 0. Factorize the first two terms, 5x, x plus 3. So x plus 3 must be a factor over here, 24. So get 5x plus 24, lots of x plus 3. So 5x equals 24, or x equals, so it is minus 24, or x is minus 3. So x is minus 24 over 5, or x is minus 3. So now, if I go into here, okay, when x is minus 3, y will be minus 3 times 3 is minus 9, plus 13 is 4. When x is minus 24 over 5, so that's minus 72 over 5. 13 will be 65 over 5. Minus 72 plus 65 is minus 7 over 5. So those are my pairs of solutions. So remember, once you found your x values, you've got to then find your corresponding y values. Okay, so a nice proof question. Oh, I thought it was going to be the end. It's not. A nice proof question. Okay, so I'm just going to draw the diagram. Okay, so there's my diagram. So I know from the question that this angle and this angle are the same. So ABC equals BCD. It tells me that in the question. Okay. It also tells me that side BA equals CD. Okay. So now we know that angle and those sides are the same. Both triangles ABC and triangle BCD use BC. So this is common to both. So in triangle ABC and in triangle BCD, we have two sides and an angle that are the same. So triangle ABC and BCD are congruent as side angle side are the same. Therefore, AC equals BD. Okay, let's hope the last question is a little bit lighter than that and a bit easier. Oh no, it's another proof question, isn't it? Okay, prove that. Okay. Let me draw my diagram again then. Okay, ABEF and CBED are congruent, where AB equals BC, which equals X, so that's X and that's X. P is the point on AF and Q is the point on CD, such that BP and BQ are 10 centimeters. So that's 10 and that's 10. Given that angle ABC is 30, prove that cos PBQ equals 1 minus 2 minus root 3 over 200 x squared. So cos of PBQ. Okie dokie. Right, so what can I see at the moment? So obviously it tells us that angle ABC is 30, and I know that cos 30 is root 3 over 2. So I'm presuming that's going to help me at some point in here. Probably why I've got this root 3 here. So it wants us to find cos of PBQ. Well, I know this length's 10 and this length's 10. Okay, but I don't know this length here. But I do know that it's the same length as AC. And I know that this is X and this is X. So I've got some X's in here. So let's find out what AC is in terms of X. So AC squared will equal X squared plus X squared minus 2 times X times x times by cos of 30. So AC squared will equal 2x squared minus 2x squared times by root 3 over 2, which is 2x squared minus root 3x squared. Okay, which is 2 minus root 3 of x squared. So that's what the length AC is. Now I know that PQ is the same length. Okay, so let's do something similar. So I can use PBQ. So I now know that PQ squared equals 10 squared plus 10 squared minus 2 times 10 times 10 times by cos of PBQ. So that's 200 minus 200 cos PBQ. And that's what PQ squared is. Now I know that PQ squared must be the same as AC squared. So this here must equal this here. So (200 minus 200 cos PBQ) must equal 2 minus root 3 of x squared. So let's take this to that side and that to that side. Oh no, let's take a factor of 200 out. 200, 1 minus cos PBQ equals 2 minus root 3 of x squared. We're getting there. Almost looks like we've got the top. So 1 minus cos PBQ equals 2 minus root 3 over 200 x squared. Take that to that side and that to that side. 1 minus 2 minus root 3 over 200 x squared equals cos PBQ. Okay, that was a tough question, guys. And that was actually a very tough paper, I think. So well done for all your hard work. Please make sure I get to the marks by by lunchtime tomorrow, preferably. That would be brilliant. Right, and I'll speak to you soon.